You know, in the world of AI, there's this massive assumption that if you want top tier speed, you have to pay a top tier price. Well, today we're going to look at a system called HCNA-3 that proves that assumption is just spectacularly wrong.
Okay, let's kick things off with a big, ambitious question. How do you get an AI model to spit out 1,000 tokens per second? Now, to put that in perspective, that's about 750 words. It's the kind of insane speed you need for a truly seamless, real-time conversation with an AI.
So, how do the big players say you do it? Well, according to a major analysis from Google's AI team, the answer looks a little something like this: over $200,000 in hardware, a colossal investment that puts this kind of power way out of reach for, well, pretty much everyone. But what if there's another way? What if you could do it with just a couple of laptops? Yeah, I know, it sounds completely impossible, but that is exactly what we are going to unpack right now. So let's really dig into this. Where in the world does a number like 200 grand even come from? Well, the thinking goes something like this. You need to run a huge 70 billion parameter model at its full uncompressed size. And to handle that kind of load, you need a server packed with 8 of NVIDIA's absolute top-of-the-line H100 GPUs. It's a brute force approach, really, just throwing the most powerful, most expensive hardware you can find at the problem and hoping for the best. But the HCNA-3 system, that's not about brute force. It's about being smart. It's an engineering solution. So let's meet our challenger. So here it is. And yeah, that's it. We've got 2 laptops. M1 is the moderator, kind of like the traffic cop, running on an Intel i7 and an older RTX 2060. The real work, the heavy lifting, happens on W1, the worker, which is using a consumer-grade AMD Ryzen 9 and an RTX 4070 Ti. No server room, no crazy exotic hardware, so how on earth can this even compete? Well, the answer isn't some single magic bullet. Nope, it's 5 layers of really clever software optimization, all stacked on top of each other, where each one just multiplies the power of the last. All right, let's walk through these 5 multipliers one by one, starting with something called quantization, and working our way up to the real secret weapon at the end of the list: speculative decoding. First up, we've got quantization. Honestly, the best way to think about this is like compressing a massive photo file into a really high-quality JPEG. You're making the file way smaller by storing the data more efficiently, but you barely notice any loss in quality. That's exactly what's happening here. The system shrinks the model down from bulky 16-bit numbers to tiny, efficient 4-bit ones. It makes the model 4 times smaller and a whole lot faster. And wow, this chart just says it all, doesn't it? That bar on the left, FP16, that's our baseline, running at full precision. But look at the one on the right, INT4. That's the quantized model. Just from that one change on the exact same hardware, the system gets an immediate 2.7 times speed boost. Pretty wild. Okay, multiplier number 2, Tensor RT LM. So if quantization was like compressing our fuel, think of this as custom tuning the engine to run perfectly on that specific fuel. It's this special software from NVIDIA that takes a generic AI model and completely rebuilds it into a super optimized engine that's made to run perfectly on their hardware. It just squeezes every last drop of performance out. And the gain here is huge. We're talking 2.3 times faster than a standard off-the-shelf engine. So think about it. We've now stacked a 2.7x boost on top of a 2.3x boost. You can see how this is starting to really add up, right? Our third multiplier attacks a huge problem: the data bottleneck. A lot of the time, your super powerful GPU is just sitting there, twiddling its thumbs, waiting for data to arrive from a slow drive. RAM disk residency fixes this by loading the entire AI model directly into the computer's blazing fast main memory, the RAM. Just look at these load times, it's crazy. Pulling a model from the cloud, you could be waiting up to 10 minutes. Even a fast internal SSD still takes about 6 seconds, plenty of time to stall out the GPU. But from RAM disk, we're talking 1.5 seconds. It's practically instant. The GPU never has to wait. It is always working. Next up is continuous batching. The highway analogy is perfect here. A single AI request is like one car taking up a whole lane. Super inefficient. This trick is like opening up a carpool lane. It groups a bunch of user requests together and processes them all at once. This rockets GPU usage from a lazy 30% to over 90%.
The goal isn't just to make one request fast, it's to maximize the total work the system can do. And finally, we get to the real secret sauce, the most advanced trick in the book, speculative decoding. This is just genius. The system actually uses a tiny, super fast draft model to just guess the next 4 or 5 words. Then the big, powerful model comes in behind it, and in one single step, it verifies that entire chunk of words. So instead of going word by agonizing word, it's just checking off entire phrases at once. This alone gives it a 2 to 4 times speed boost.
Okay, so let's recap. We've shrunk the data, we've custom-tuned the engine, we killed the bottleneck, we carpooled the requests, and we added a genius little guesser model. What on earth happens when you smash all of that together?
Each step gave us a nice boost, right? But when you multiply them all, the final result is, well, it's just staggering. 498 times. Let that sink in for a second. 498, that's how much more cost-efficient this little laptop system is compared to the giant server farm. For every dollar you spend, this system delivers almost 500 times more performance. It's not just a little better, it's a completely different league. Let's just put it side by side. It's almost comical. On the left, you've got the brute force method, 8 H100s costing 200 grand. On the right, the smart, engineered reality, a single RTX 4070 Ti you can buy for around 900 bucks. And just look at that bottom line. You are getting the same class of performance with nearly 500 times the cost efficiency.
So, what's the big lesson here? What's the real takeaway from all this? This quote from the source material just hits the nail on the head. The server cluster is the answer if you just want to throw a ton of money at something. The laptop system is the answer to an engineering problem, and in the end, it proves you can either throw cash at a problem or you can throw intelligence at it. And in this case, intelligence didn't just win, it absolutely crushed it. And that really leaves us with one final huge question. If this kind of supercomputer-level AI performance is no longer locked behind a massive 6-figure price tag, what impossible goals are suddenly within reach? What are we all going to build now?
Thanks for tuning in.